Hello everyone, and welcome back to the channel. Today, we're diving into a topic that has fascinated humanity for centuries. Time travel. Is it a mind-bending possibility waiting to be unlocked by science, or will it forever remain in the realm of science fiction? Let's find out. When we talk about time travel, we're actually talking about two different directions. Forward and backward, and believe it or not, we are all time travelers in one sense. We are constantly moving forward in time, 1 second at a time. But can we speed it up? According to Albert Einstein, the answer is a resounding yes. This is where his theory of special relativity comes into play. One of its core ideas is something called time dilation. It states that the faster you move through space, the slower you move through time relative to a stationary observer. Imagine you hopped on a spaceship that could travel at 99% the speed of light. If you took a 5-year trip, you'd return to Earth to find that decades, maybe even centuries, have passed. Your friends and family would be long gone. You would have effectively leaped into the future. This isn't just a theory. We've proven it. Astronauts on the International Space Station, orbiting Earth at about 17,000 miles per hour, experience time just a tiny fraction of a second slower than we do on the ground. The effect is minuscule, but it's real. GPS satellites even have to account for time dilation to give us accurate locations. So, traveling to the future, it's theoretically possible. We just need a much faster ship. But what about the more tantalizing idea? Traveling back in time. This is where things get really complicated and, frankly, a lot more controversial. Einstein's other groundbreaking theory, general relativity, suggests that massive objects can warp the fabric of space. Think of it like placing a bowling ball on a trampoline. It creates a curve. A strong enough gravitational field could, in theory, bend space-time so much that it folds back on itself, creating what scientists call a closed time-like curve. This is essentially a loop, a pathway to your own past. One theoretical construct that could allow this is a wormhole, or an Einstein-Rosen bridge. Picture a tunnel connecting to distant points in space-time. If you could create and stabilize a wormhole, you might be able to step through one end and emerge at an earlier point in time. However, the energy required to create and keep a wormhole open would be immense, possibly requiring something called exotic matter with negative energy density, something we're not even sure exists. It's a huge hurdle. Even if we could overcome the physics, traveling to the past opens up a whole can of worms. The most famous is the grandfather paradox. What if you went back in time and prevented your grandparents from ever meeting? If they never meet, your parent is never born, and then you are never born. But if you were never born, who went back in time to stop them in the first place? It creates a logical contradiction that seems to make the past a no-go zone. Some physicists have proposed solutions to these paradoxes. One idea is the Novikov self-consistency principle, which basically says that the laws of physics will conspire to prevent any paradoxes from occurring. You could go back in time, but you wouldn't be able to change anything that would alter the future you came from. You might try to stop your grandparents from meeting, but you'd fail in some comical, unexpected way every single time. Your actions would already be part of the history that led to your existence. Another mind-bending idea comes from quantum mechanics, the many worlds interpretation. This theory suggests that every time a quantum event has multiple possible outcomes, the universe splits into different parallel timelines, one for each outcome. So, if you went back and changed the past, you wouldn't be altering your own history. Instead, you'd simply be creating a new, branching timeline. Your original universe would remain untouched, but you would now exist in an alternate reality that you created. No paradox, but you'd be stuck in a different world forever. So, where does that leave us? Traveling to the future seems physically plausible, though technologically far beyond our current capabilities. Traveling to the past, however, is fraught with theoretical and logical challenges that may be insurmountable. The paradoxes suggest that the universe might have some fundamental rules in place to protect its own causal structure. Perhaps time, as a one-way street, is a feature, not a bug, of our reality. While we may not be building DeLorean time machines anytime soon, The quest to understand time continues to push the boundaries of physics and our imagination. It forces us to ask deep questions about the nature of reality, causality, and our place in the cosmos. Is time an absolute, flowing river, or is it a landscape we can one day learn to navigate? For now, the past is history, the future is a mystery, and the present is all we truly have. What do you think? Is time travel possible? Which paradox do you find most fascinating? Let me know your thoughts down in the comments below. I'd love to hear them. Thank you so much for watching. If you enjoyed this journey through space-time, don't forget to hit that like button. Subscribe for more deep dives, and ring that notification bell so you never miss an update. Until next time, stay curious.